Okay, we are Mechanical Minds. My name is Jeremy.
Kenny?
Aiden.
Peter?
Chrissy?
And this is our shooting robot project. Alright, the outline for our presentation, we're going to talk a little bit about some of the individual work that we did as a team, go over some of the ideas that didn't work, some of the ideas that did work, some of our programming, and then you're going to watch a video of our guy firing. Okay, so the project requirements, we had to shoot the ball, it had to go somewhere, design, and it had to self-reload.
Alright, so me and Kenny and I, worked on the ball feeder. Complications, a lot. The thing, first off, wouldn't hold its position, and so the ball just kind of flopped wherever. And so we had to add a lot of Legos to keep it held in place for stability. Ball release, there are times when the ball just wouldn't come out. And that would not be good. And Kenny was kind of a problem, because he was just in the way. So.
Right. Alright, throughout this whole project, the one thing that stayed mostly the same was the ball feeder, even though we did take it apart and rebuild it 3 times, I think. We always stayed with the same gravity fed mechanism, where we would have them all in a line, and our complications were literally how do we just push the ball over the edge and into the feeder.
Alright, so Jeremy and I, and Peter, we all put together the shooting mechanism. We had a fair amount of complications, like a lot of complications. We also had a couple ideas, so I think there's 3 main ideas that we worked with. The first one was a scorpion idea, and we thought that was a really cool idea because it was different, it was innovative, and it just looks cool. Some of the issues that we came with is that it was just generally messy. It was difficult to really get it to work and function the way we wanted it to. And then once we got the thing completely set up, it wasn't shooting the way that we wanted it to. And we weren't getting enough power with it. We wanted to have more of a kick. We were going to attach a piece to the end of it, and so it kind of kick it as it sprung out. But once it kicked, it didn't go very far. It didn't give us the correct amount of power that we wanted.
And we also realized it wasn't practical to where we had our ball feeder. We didn't have enough pieces where we could elevate it high enough to get a good angle on target.
So one of the second ideas that we were rolling with was a kind of a golf club idea. It was bulky, it was heavy, it was too much weight. Originally we started to where it would sit up high and swing down and kick the ball, and the motors at the end with the wheels on there would provide spin. That spin would cause the ball to lift. And then we realized not enough pieces for that, so hey, let's turn it on its back. We'll have it catapult the ball, still provide the spin and provide lift, but the thing was just heavy. And next slide. So we scrapped that, and we went with some of the same concepts. We decided to go with the catapult design, where the ball would run down this track system, which is this is a leftover from our last design. Land in here, shoot it. So that was, this design is similar to what we ended up with for our final design, just because we were able to better control distance, better control power, and the angles that it would go with. So again, showing a little more of the original design of the ball feeder at the end, rolling down into the arm, and then taking off that way. So this is our final design that we went with. As you can see, as Kenny was talking, the ball feeder is essentially the same. We changed it into a back load system instead of a front load system, drops it right in and shoots it away. So we got a couple videos here Should be short to show you. So that's kind of showing some of the launching angle problems that we were having. There was a number of things that we did to combat those problems. We stiffened the front, put some blocks on here to stop it at the right angle that we wanted to control its release when it came out. Okay. So this is showing another attempt. It was kind of hard to see, but we put a string on the backside to try to play around with the different stopping angles to find the optimal angle. So that string on the backside was adjustable so that we could control where the arm stopped in its travel.
This is when it starts shooting.
So it's getting everything tied in and really fine tuning the trajectory.
So that's
about right.
Yeah, so at this point we're getting it to shoot, but then it, as you see at the last part, it doesn't really quite make it towards the end. We couldn't get our 3 full rounds in.
So we were having a lot of programming issues where where the drive motors for the arm with the programming were causing it to bind up. It wasn't it'd go through its forward motion, it would stop here, but then just the residual power that was in there was causing the gears to bind up, so it wouldn't want to transition to the next series of the programs, or it just really caused it to goof up where both of these motors are trying to run in different directions for some odd reason. Still don't fully understand it, but that's what happened. So as far as the programming goes, we couldn't run it in a loop just because of the goofiness that was going on with the motors. So we had to run it in a full series, and then we had to run it with the pressure sensor for the trigger so that all of the tension would go out of the gears in the motors, and then we could initiate it again with the trigger to let it go.
And then at this point, we also added the rubber bands, which would help catapult the ball. It was a little bit more force than just the motors throwing the ball. So I think about doubled the throwing distance there.
So this is kind of showing the problems we were having with the feeder, where with 3 balls it was doing, it was dropping down into a multi-feed. It was trying to, with 3 balls in there, it would drop 2 down on the first descent. So we changed the feeder design a little bit so that the arm of the feeder would help stop the second ball from dropping in, and there's a little rubber band on there to provide a little bit more friction to keep that from falling in.
And we also added little pegs in between the bars holding onto it, so as it was going down, it would kind of shake around, slow it down a little bit.
That's kind of where we're at.
Consequent to having it being gravity fed, just the weight of the 2 balls in the back and just push them straight out.
Let's just do the first.
No, not that one.
Go back.
Go back.
Just for laughs.
The
Just
first
that
one.
one. So if you haven't noticed on our ball feeder, there's that is our little Aiden, and she gets some fantastic distance. All right, so now we'll show it in full operation from the back, just in case it doesn't work when we get to the distance competition. You can at least see it working here.
But you can definitely see the design of the ball feeder right there. It kind
So-
of spins and pushes the ball.
We
pushing the trigger.
To see if he's willing to do certain things, because he could go over there with a abortion, and I'm sure.
You guys can't hear it. After it shoots, it says hooray.
Alright, and that is our robot. Are there any questions? Alright, thank you
Nice.
very much.
Thank you.